Hi, Geoff.
Hey, Mark.
So you're now live, so we have an audience, and again, we're excited to hear your presentation. So before I formally introduce you, would you like to just share your slides, and I'll
Sure.
just check
Get
that they're
them going.
working.
Okay.
Perfect.
Forward back.
Yeah, absolutely perfect. So once again, thank you very much in advance. Really appreciate you taking the time to present for us. To formally introduce you, this session will feature our event partner, Scitara. And for this session, we have Geoff Gerhardt, who is Chief Technology Officer for Scitara, and he'll be presenting on accelerating scientific discovery through true digital transformation. So I'll turn over to you now.
Okay, thanks, Mark. And thanks everybody out there that's listening. This is the first time I've done a virtual presentation like that, just staring at a screen. So should be interesting. Anyway, so what I'm going to talk to you today about is the Scitara's DLX platform that we've developed, and specifically around how we connect into devices and applications that are on-prem, and some of the challenges that we've had and solutions we've come up with to be able to connect devices and applications that exist on-prem around some network security concerns. So just a bit of background. Scitara started about 3 years ago, and what we've developed is what we're calling a scientific integration platform. You can think of it as similar to other applications or iPaaS or integrated integration platforms as a service, like Zapier or Boomi or MuleSoft. These are integration services that provide integration of business applications. You get a Gmail, and then you can automate putting the attachment into your Dropbox. We're an iPaaS, but we are specifically for science. So we provide connectivity into all of the assets that exist in the lab. As you'll see, simple devices like a pH meter, but also applications like chromatography applications or connectivity into things like OPC bioreactors, but also web services. We provide a lot of the connectivity into business applications like OneDrive or Office 365 Excel or Box, but also specific science-based web service applications like ELNs and IDBS, Polar, Benchling, things like that. So really what we're trying to do is provide true data mobility. Sort of release data from proprietary standards and make it so it can be moved around the lab as effectively as possible. So quite often when we go into a lab, we see a situation like this. A lab has a variety of informatics applications they use to manage and direct lab data around the lab, as well as things like PCB instruments, chromatography instruments, standalone system instruments like pH meters or balances, streaming data systems like a bioreactor. And it's actually not that difficult to create individual integrations. So there's, of course, lots of LIMS have integrations into standalone instruments or chromatography systems. But as you begin to connect the entire lab, all of these point-to-point integrations or proprietary integrations get difficult to manage because they're all unique and they all have different interfaces to them. What Scitara is trying to do is provide a more uniform connectivity platform. We do the work of creating connectivity into the lab-specific applications and devices, and then a communications network that allows all of these now to communicate once they're all talking the same language. And once they're all connected, then we have an automation layer that can be put on top that can automatically move data from each one endpoint to another. So the way we provide this connectivity, once we have our system installed, it's a cloud-based system. we begin to connect all of the devices and applications. We really break these down into three different types. One is devices or sensors that exist on-prem in the lab, and these are balances, pH meters, particle counters, temperature sensors. To connect these, we have a few options, but the one I'll talk about first is an IoT box. It's a small Linux device that has a variety of connectivity options. The most popular is RS-232 that connects into the device, and it can speak that device's language and then connects up to our cloud service. We have a universal RS-232 connector that can configure to work with most lab devices. And to create a new connection, you start in our platform, and it walks you through the process of setting up a connection. You'll specify the device. In this, it's the Sartorius entrance balance. It'll give you an association token that it can use to authenticate, and I'll show you how that happens. And once you walk through this process and your device comes online, you'll see it on your dashboard. That's a picture of the device here beside a network Toledo balance that's connected to that. So the other type of connections we have on-prem are application connections. So these are chromatography systems, plate readers, things like LabX, or protocols like OPC. So quite a lot of bioprocess equipment uses OPC as a connection protocol. We have a connector that will speak that language as well. And so we also have a Windows file connector because a large number of scientific applications don't have an API, but they exchange data by dropping files or being able to pick up files. So each of these, we create dedicated connectors that communicate with that application. It's usually a Windows application based on the API it has. So Chameleon has a very rich .NET connector API that we work with Thermo to create a connector that will allow these to participate in the DLX platform. So again, in here, you'd go on, if you want to create a new Chameleon connection, it would walk you through the steps to set up the connection. And ultimately, it's going to ask you to download the agent that you would install on the PC that had Thermo Chameleon software on. And that would then provide the connectivity, and you would see a connection icon for this connection on your DLX dashboard. The third kind, and the last kind of connectivity we would provide is for web service connections. So we have connectivity into a lot of the primary business applications. Snowflake is a data lake application a lot of folks use. OneDrive, Excel, Office 365, the Google Sheets, Google Drive, Box, things like that are typical Windows business applications that labs use. But then also the more specific to the lab, things like ELNs. We connect to most ELNs, things like Signal, PerkinElmer Signal Notebook, IDBS Polar, Benchling, and a lot of the major LIMS platforms as well. These are all web-based interfaces, and so we use the API that's provided by each of these. And we also have a universal web service connector that can be configured to work with any API that we currently don't have a bespoke connector for. So, and again, in a similar way, to add a new connection to your dashboard, it walks you through the process. For something like Google Sheets, it provides an OAuth flow that you can give your authentication parameters, so it allows you to get access to your Google Sheets. And then once you've created this again, now you have another connection in your dashboard that you can use to start your automations. So once we've been able to configure all the connectivity in the lab, this is a typical network topology for a system. So the Scitara DLX is a cloud-based application. We typically host it in AWS, although we can host it in Azure. it's either a multi-tenant system or a single tenant. Really, the difference between these in a multi-tenant implementation, we update the DLX platform at least 3 times a year. So all tenants in that will get updated. For those, quite often large pharma, which have a validated system, they want to have more control over when their application actually gets updated. So we can run a single tenant for that, those types of customers. And they have a development, a production, and a validation system that they can easily move between upgrades in a more controlled way. But it is a cloud-based system, and so connectivity to other cloud-based applications like these cloud services is relatively straightforward. Quite often, customer will have cloud-based resources that will use a web service connection to connect into as well. But the more challenging way to provide this overall connectivity is for these on-prem resources. So as I mentioned, for things like balances, particle counter, pH meters, we have an IoT box that connects into that, usually RS-232. And then for these applications, like sort of things like a bioreactor that communicates through OPC or thermochromeleon chromatography system, we have an application that gets installed on that PC and runs as a Windows service, and then connects to that application through its API. And then the first thing that these do when they're installed is they are given an initial authentication token, and they reach out to the DLX platform and announce their presence. And the DLX remote connector service will validate the authentication token it got initially. And then once that's been validated and the authentication happens, that communication is upgraded to a bidirectional persistent connection. And so now all of these devices and applications are connected in real time to the DLX platform. And what it means to be connected is that any of these devices or applications can publish an event on the system. A chromatography might publish an event that a sample's been analyzed, or an OPC bioreactor could publish a new bioreactor conditions, or a pH meter might publish that it has taken a new pH meter. But they can also execute actions. And so you might want to send a sample set to Chromeleon, or send a plate instructions to a TCAN plate reader, or ask a bioreactor to send back its current conditions. And so all these both on-prem devices and web devices now are communicating in real time, publishing events. And that's where our automation platform can take over. It's an event-driven system that can create automations. But as I said at the start, this is a real challenge to be able to connect these on-prem systems, given quite often we're dealing in pharma situations where they have a dedicated network that often there's a firewall involved. Because our connectors reach out, and our DLX application isn't attempting to reach into the fire, we don't need to open up external firewall rules. But most large pharma labs have a dedicated lab domain that even restricts on what on-prem resources can reach out. And quite often, these firewall rules are as an IP basis. So each IP address needs to have a configured rule that allows what external resources and IPs or domains it can reach. And that can be quite demanding to be able to ask, if you have thousands of these devices and applications, each one of them needs a firewall rule. This is something that we've encountered and come up with another solution that doesn't require that sort of configuration. So for a small biotech lab or an academic lab, this is often a good way to go. It's if these devices can reach out to our application, it's a very rapid way to get going. But for large pharma labs, what we provide is we found that these serial to network devices that convert RS-232 or 485 to a network protocol can be used to connect these devices, but then we have a DLX agent that's an appliance that can sit in this dedicated domain that can now run all the drivers necessary to communicate with all these individual simple devices. And then it reaches out through one IP address to the DLX. So there's only one IP address that needs to be configured to communicate, to allow it to communicate to our DLX platform. But that still leaves all of these applications that need, again, separate configurations. So one thing we're working on right now is upgrading the DLX agent. So it can also act as a relay for all the application connections as well. So again, both all of your on-prem devices now go through this DLX agent, as well as all your applications. So there's only one firewall rule that needs to be made to penetrate out the firewall, which we found to be a much more amenable way for a large, highly protected network to be able to be configured. So once everything's connected and you have all of your devices and applications and web services publishing events or online and can execute actions, we provide an automation platform that users can then configure how they want all of these connected lab assets to communicate. It's a very easy drag and drop sort of interface that starts we call them orchestrations. Every orchestration starts with some sort of a trigger, and then all of your connections can pass data down through in a series of steps. So this is one where a user's walked up to has a sample from a bioreactor and is going to perform an analysis on an instrument. So this is typically how an automation might work. An automation might start with a user in an ELN like IDBS's Polar platform. They may click on a button within that platform that's, in this case, they want to send a sample set that's in that ELN to Chameleon and then send a notification out to an analyst to get that sample analyzed. So in this, that would publish an event on the DLX system. And that event would, within IDBS, we would be able to render a user input form that we could get the user's Chameleon authentication details. They can select a project, whether they would do this, put the sample set and the method set. And then quite often that table that existed in IDBS is probably not in the right format for that Chameleon wants it for a sample set. So we allow users to define a transform function that would transform that the shape of that data into how it needs to be for a Chameleon. So it would be sent, the sample set would be created on Chameleon, and then you have things like a notification actor that could send out an event to a notification to an analyst so they can go and then analyze that data. So just to review, an event is generated by IDBS. We provide a user input that they can get the necessary information. A small code snippet can be put in to transfer any table data from IDBS into the format for the chromatography system. The sample set is created, so an action is sent out to that connected chromatography system, and then a notification sent. Another typical workflow is a user walks up to a simple device and they need to perform an analysis. So in this case, it's a user has a sample in their hand. They have to walk up to a balance and weigh the sample, and they want that data, that weighed sample data, to go off to a LIMS or an MES system. So we use QR codes quite a lot. So there might be a QR code placed on the sample that would have embedded in it that sample ID and the analysis that needs to be done on it. If the user walked up to that and had that sample in their hand, they click on the QR code on their mobile device or on their tablet, it would render an execution process where, in this case, they may need to select the batch ID that the sample is for, the date of the reaction. This might be a bioreaction sample, any comments. And then it would provide an interface that showed to a Sartorius balance, for example, where it shows the live weight because we're communicating live with that balance. and the user could take the reading, perform actions like zero or tear the balance, add memos. You notice it has metadata associated here, so it knows where to put that the sample once the weight's been taken. So the user would complete this reading on the balance, and the data would automatically then be routed back into the LIMS or MES system. So again, the code is scanned by the user on the mobile device. That renders a web page that allows the user to take some information. It then renders a web page that's a live interface to the device. And then once the sample is taken, the data is automatically routed to the LIMS system. And these sort of orchestrations are easily created by the users within the orchestration editor. So once the system has been set up, we have all the lab informatics applications connected, on-prem devices and applications. And then we have data orchestrations that allow data to automatically flow between these. We found on top of this, our customers and partners can then use this platform to build applications on. So things like automated data archival or instrument management systems, or quite often, customers want data pushed directly into data lakes as part of a workflow. So you may have a workflow where that chromatography from your ELN, a chromatography sample set is created and then it's analyzed. You may want the data sent back to the ELN, but also pushed to a data lake, and that we can push this highly contextualized data from the chromatography system also to that data lake where analytics could be done. And then things like analytics dashboards. You now have this stream of event-based data coming out of your lab that is highly contextualized. You can begin to do data analytics on. Just a few of our partners. We're always cultivating more and more partners. That's sort of the a critical part of our of Scitara. We strive to be vendor neutral and provide interfaces to all of the different lab assets. And we look forward to partnering with any lab informatics, business application, or instrument provider that wants to provide connectivity. Once we have connectivity onto our platform, if you're an ELN, you now have connectivity into every application or asset that we have a connector for. So that's an introduction to DLX and how we provide connectivity in the lab. And as I say, one thing I wanted to get some discussion around is that connectivity into these private networks and some of the challenges that you have providing connectivity into these on-prem devices. Like if anybody has any questions or interest in that, I'd love to discuss further.
Hi, Geoff. Thank you very much for. Can you hear me?
Yes, I can.
Perfect. Thank you very much for the presentation and for taking the time to run through everything. I've reminded everybody on the Q&A on the discussion tab that they can drop questions across. So another reminder to the audience: if you've got any questions, drop it in the Q&A tab. We've got a couple of minutes to run through things. I'd also like to remind you that Scitara are a sponsor of the event, and they do have a virtual booth as well. So Geoff and his team will be over at that virtual booth in the next break, and you can feel free to go see them, go meet them. You can pick up the materials, you can drop them a message, you can leave your contact details. You can even arrange a one-to-one meeting, so you can have a Zoom style, team style meeting as well, face to face, like we are now. We also have HiBite as well, who are a sponsor. So take the networking break to engage with one another, and obviously the sponsors as well. So we've got a question that's just dropped in. I'll read it out for you. Does the DLX agent perform analytics on the edge, or is it just a gateway? latency for processing loads of data on the cloud is a concern. A question and a
So the agent itself doesn't do any processing. It is really just a relay. We will be adding buffering capability and being able to, if an application or an instrument gets a request but it's gone offline, that request will then be sent once it comes back online. But currently, it's just it's a relay. Latency and processing loads. Things like one thing that DLX currently does is it handles result data. We will be adding in the future the ability to handle large files like a microscopy file, and then bring that up and keep it on the edge so it doesn't sort of bog down our event queue. Yeah, so anyway, in answer to your question, it really is just a relay to be able to relay the events and actions to and from.
Perfect. Doesn't look like we have any other questions dropped in as yet. So on that note, I'd like to thank you again. Thank you very much for taking the time to present. And another quick reminder to the audience that Geoff and the team will be over at their virtual booth. We have a break now, so take a break for 30 minutes, and I believe the next session takes place at 10:35 Pacific time. So do come back, tune into the presentation from Stephen Driver, Global Energy Program Director, Principal Engineer from Sanofi. Once again, Geoff, thank you very much, and
Thanks, Mark.
we'll see you all again shortly. Thank you.